Hi everybody, and welcome to this lesson on factoring tricky trinomials. That's trinomials that have a number in front of the x squared term. So we're going to look at how to do that. It's section 5.5 in the McGraw-Hill-Ryerson textbook that we're using for grade 10 math.
And the first thing we'll do is a few minds-on questions together here. The first one is x squared plus 13x plus 42. You should pause the video and try these out yourself, and then you can check the answers with me in a minute. We're trying to find two numbers that add to 13 and multiply to 42. So we need factors of 42. And so you could start listing all the factors. You don't have to list all the factors, but we have 1 and 42, 2 and 21, 3 and 14, and 6 and 7. So if you see it directly, you can just go ahead and directly get that answer and hopefully not do crazy things on your screen like mine. But you have 6 and 7. So that means that I'm going to put x in the first bracket, x in the second bracket, and they're both positive, so plus 6 plus 7. The second one, we have two numbers that add to -4 and multiply to -21. So we want factors of -21. Well, because they add to a negative number, the larger factor is going to be negative. So I can have that, or I can have that. 3 minus 7 gives you -4. So that's the correct, those are the correct factors. So x, and I'm going to have plus 3 and minus 7. That's my answer for that one. Now this next one's like, well, hold up a second, Mr. Hamilton. Isn't this the whole, what the whole lesson's about? Well, actually, you can do this based on what you already know. The first hint I'll give you is that we can always do something when we come to a question before we do any of this type of fancy factoring stuff. I'll give you a little hint. It starts with the word common and ends with factor. If you put common factor together, wow, you're on it. That's good. The thing we can do is we can common factor 2 out of this. So this is a common factor that. We always can common factor first. In fact, we're always going to look for a common factor first. It can make our life a lot easier if we can find one. Because we found that 2 is a common factor, now it's a simple trinomial like we covered in our last lesson. So it adds to the middle term, multiplies to the last term. And so we need factors of 5. You probably see this one directly. 1 and 5 wouldn't do it because that would add to a positive number. So, but if we make them both negative, that would multiply to a positive and add to a negative. So those are the factors that we want. So 2, we're going to have x, we have -1, and we have -5. And that's how you go about factoring that. Now I want to introduce you to a factoring flowchart, just so we can see a picture of how we can factor in the different ways. If we can common factor something, we are always going to do it, as we just saw in that third minds-on question. We were able to common factor the 2. Once we have got common factored as much as we can, we're going to continue moving down the flowchart here, and we're going to see if we have 2 terms, 3 terms, or 4 terms. Now, some of these things will be covered in a future lesson. Difference of squares, we've seen the expanding, but we haven't actually factored using a difference of squares. So that'll be in a future lesson, as will this perfect square trinomial. That will be in a future lesson as well. Today, we're going to focus in on the simple trinomials that we've covered yesterday, but specifically the tricky trinomials. We're going to look at those, and then we're also just going to look at one example of factoring by grouping. That follows from a couple of days ago. So here's the example for a factoring by grouping. If I have something like 5x minus 15 plus 9x minus 3x squared. What we learned a couple of lessons ago is that we can build a wall in the middle. We're going to common factor to the first 2 terms and common factor to the next 2 terms. Common factor to the first 2 terms, I get x minus 3. The common factor of the next 2 terms is 3x, and I get 3 minus x. Well, watch this. There's a little trick we can do here, and if we have 3 minus x, and we multiply it by -1, that -1 would expand into those, and that would give us -3 plus x. Well, -3 plus x, if we write that in the other order, we can write it as x minus 3. Notice that that now is the same as what's in the first set of brackets. So all I can do is if I pull out an extra factor of -1 out of this bracket right here, I can make this -3x, and then that bracket is going to become x minus 3. So this would become 5 times x minus 3. We're going to pull out that factor of -1, which is going to make this -3x, and it's going to switch the signs inside to x minus 3. And I'm just switching the signs in orders as I had done over there at the right. So now I've got the same thing in the brackets, and I can write that as x minus 3 because that's the common multiple to both of these two parts, and I'm going to write 5 minus 3x there. So there's a factoring by grouping example. Let's go down and look at a simple trinomial example now. Simple trinomial, like we just had up above, we could write in 2x squared minus 12x plus 10. I'm writing that one specifically to remind us that we can common factor first. I think it's important to remember to common factor. It's going to make your life a lot easier in many cases. And so we're trying to find two numbers that add to -6, multiply to 5. You don't need to write out factors of every time. You can just write what those factors are. It's -1, -5. And so this became 2 times x minus 1, x minus 5. All right, we'll fill in the rest of it later. Let's move on to considering what these tricky trinomials are and how those work. So what we're going to focus on first here is how would you actually go about factoring one of these things? Well, it's very similar to what we had before. Just notice a couple of things as I do this example, and then I'm going to go over the handout in the steps in a minute. We need two numbers that add to 8. That hasn't changed. Still adding to the middle term. But now the first and last term is what it needs to multiply to. So 3 and 5 makes 15. So we need two numbers that are going to add to the middle term, multiply to a times c. Add to the middle term, the b term, multiply to the first times the last. A times C. And so what we're going to do here is we're going to try to, again, find factors. But in this case, it's factors not of 5. It's factors of 15. So we're going to go factors of 15. We have 1 and 15. We have 3 and 5. Hey, what do you know? 3 and 5, in this case, end up being the two factors. It's really nice because they're also the two numbers there. Won't always be that case. We'll see that in future examples. But in this case, it is. And so what we're going to do is we're going to do what we call decomposing. When you hear the word decomposing, you probably think of something like leaves or a log that rots over time. It breaks down into nutrients that get into the soil. Another way to say decomposing is breaking down. Decompose equals breaking down, or in our case, breaking apart. So when you see the word decompose, think things break apart. In this case, we've got our two factors, and I'm going to literally write this 8x broken apart with the two factors. So I've got plus, I'm going to write plus 3x plus 5x plus 5. I've broken the 8x into 3x and 5x. Those were my two factors, 3 and 5. And so now what I'm going to do is I'm going to factor by grouping. I'm going to take the first two terms, and I'm going to say, what's the common factor there? Well, it's 3x. This is going to give me x plus 1. And I'm going to take my second two terms, and I'm going to say, well, what's the common factor there? Well, it's 5. This is going to give me x plus 1. And just like we've done before, because x plus 1 is common to both halves of this, x plus 1 is written first, and then we have 3x plus 5. You could have written that also as 3x plus 5 times x plus 1. The key thing to get across here that's new to us is this decomposing step. And I'll just draw that in a different color here for us to see. This is the step that's key. That's what we need to be able to do. And then we also need to recognize that it multiplies to the first times the last term. Those are really the only two things that are new to us in this lesson. And then we go ahead and factor by grouping, and we solve the question. We finish factoring it. All right, let's look at the actual handout. Let's walk through that together. Factoring tricky trinomials of the form ax squared plus bx plus c by decomposition. I'm not going to read all the words here. There's a lot there. You can read them yourself. But the key thing there is it says decomposition. We want to decompose these things, and we want to recognize that I'm decomposing into two terms. The x is going to decompose into two terms. So the first thing we want to do is rearrange if necessary. Here we have 9x squared plus 21x minus 8. And it's in the x squared plus bx plus c, so there's no issues with how it's rearranged. But if it didn't have an x squared followed by an x followed by a non-x term, we'd have to rearrange it into that form. The second thing we're going to do is make a t-chart. So you can see here that we're writing two numbers that add to the middle term, which is 21, and multiply to the a term times the c term. Remember, the sign in front of the term matters. So in this case, it's 9 times -8. So they need to multiply to negative 72. Well, now we need to find some factors. We can write them out just like we did before in a chart if we want. If you see it directly, you can just write out what the factors are and move ahead with it. But factors of negative 72 are listed here, and you can take some time if you want to just write those out. Notice here, because we know it adds to a positive, the bigger number is positive. Otherwise, it would add to a negative if the smaller number was positive and the bigger number were negative. So negative 3 times 24, well, the sum of that is 21. So they multiply to negative 72, they add to 21. Excellent. We can move on there. So I'm going to circle those, as it says there in step 4. Moving on to the other side of the page here, it says we're going to split decompose the middle. So we're going to break that 21x into negative 3x and positive 24. Remember, the two things we found were negative 3 and 24. Those were our factors. So we've broken the 21x into those two factors with the x's with them. That's all we had to do. That's the only real new step for us here. So now I go ahead and I factor by grouping. I can draw a dotted line here. I'm going to then common factor to the first two terms, which gives me a 3x down here. I'm going to common factor to the next two terms, which gives me 8. And then in both of the brackets that follow, I get 3x minus 1 because I common factor the greatest common factor, and it worked out just as we expected. So now I can write that out as 3x minus 1 because that's the common factor times 3x plus 8. If you want to read over that handout to get more detail, by all means, go ahead and do that. Let's look at two more examples together before we're done this video for today. The first one is this: factor 6x squared minus 7x plus or minus 10. So we need two numbers that add to negative 7 and multiply to negative 60. Remember, it's a times c. So it's negative 60. So what are the factors of negative 60? Well, factors of negative 60, remember, because we want to add to a negative, the bigger number must be negative. That doesn't add to negative 7. What about 2 and negative 30? Nope, nowhere near it yet. 3 and negative 20. We're getting closer. 4 and negative 15. Not there yet. 5 and negative 12. There it is. 5 and negative 12 add to negative 7. So we go ahead and we break this apart by decomposing it. So 6x squared. We're going to break this negative 7 into plus 5x minus 12x minus 10. This gives me, now if I common factor to the first two terms, the only thing I can common factor here is an x. So I'm left with 6x plus 5. And the only thing I can common factor to these is a negative 2, which leaves me with 6x plus 5. Notice that if I expanded the negative 2 back out, I'd get negative 12x and negative 10. So I've got the same thing there in both of the brackets, so I can write this as 6x plus 5 times x minus 2. And we factored that using, we factored that tricky trinomial. Now this next question has a y and a y squared. But if you notice the one before, the one we just looked at, that's the only difference between this one and the last one. So the same rule applies. We need two numbers that add to negative 7, multiply to negative 60. And those two factors we found earlier are 5 and negative 12. Okay, well, let's do the same thing, but just keep an x and a y in that middle term when I decompose it. Let's see what happens. So we get 6x squared plus 5xy minus 12xy minus 10y squared. I'm going to break this apart and common factor to the first two terms and to the last two terms. I can take again just an x out, so I'm left with 6x plus 5, and I still have a y there. So 6x plus 5y. On the other side, I can common factor again, just you would think just a 2, but now we also have a y that we can common factor. It's going to common factor that as well. That's going to give me 6x, and I'm going to be left with plus 5y. If you expand that back out to check it, it gives you negative 12xy minus 10y squared. So now we have a common factor here and here, and so we can write this out just as we've done before. 6x plus 5y and x minus 2y. And that's all there is to it. That's the only difference you have to do. Just keep the x and y there and do this very same step.